All right, ladies and gentlemen, welcome back. For example 2, we're talking about finding a theoretical probability. Almost all of this is going to be based on theoretical probability, just so you know. I don't think we actually switched to experimental. Those are earlier stages. Now we're getting into, because hopefully we understand the concept that if we run the experiment enough times, it actually approaches or becomes equal to the theoretical probability. Now, with that stated, we can talk about that more if you have questions. With that stated, that's one reason we focus on theoretical probabilities. Now, there's some difficulties there. We have to be able to think of all the different variables, and that's one reason sometimes we do theoretical with experimental, because we know what it's supposed to be according to theory. We run the experiment and we go, oh, wait, there's some things we forgot in the theoretical, or hey, here's some things that weren't accounted for in the experimental. So we need to be able to balance it out so it's accurate information and probability. So we have accurate chances. Now, with that said, let's move on. We're finding a theoretical probability that a student guessing exactly 2 correct answers when they guess on 4 true-false questions. So on a true-false questions, you only have the ability to be right or wrong in that. So we have the idea that you could be completely wrong. That means I stands for incorrect and C is going to stand for correct, so right or wrong. Writing an R and a W, not as easy. So we find if the outcome were you got none right, there's only one possibility of that. Okay. That's not what we want. We want the possibility of 2. So we look at here, we have 1, 2, 3, 4. Now the reason I'm counting these up is because at the end, I need to know the total possibilities that there are. And I need to be able to compare what I want to how many there are. So here is what I want. I want the possibility that I got 2 of the 4 correct. So 1, 2, 3, 4, 5, 6. There are 6 possibilities or 6 ways I could have gotten 2 correct. Because I don't care about order. I don't care if I got the first and the third right. I don't care if I got the first and the fourth right. I don't care if I got the second and the fourth right. It doesn't matter. The possibility, there's 6 possibilities where I got 2 right, no matter the order. And so I need to account for all 6 of them. Now, moving on, there's still the possibility I could have gotten 3 right. So there's 4 that fall into that category. And lastly, we've got the possibility I could have got them all right, and there's only 1 possibility for that. So what I see here is I have 1 plus 4 plus 6 plus 4 plus 1. Well, that's 11 plus 4 is 15, 16. There is 16 total possibilities. And 6 of those possibilities is what I want to be true. So I'm going to compare my 6 to that 16. And I'm going to get 3/8, which in total is 0.375. And that is equal to 37.5%. And one thing we should be able to be used to by now is being able to read a fraction, a decimal, and a percent to all mean the same thing. I have a 3 in 8 chance is the same thing as I have a 37.5% chance, which is the same thing as 0.375. So the probability itself is usually done in a percent. So you're going to have to convert that fraction into a percent. But for what we're doing, as long as you're accurate in one of those 3, so if you mess up converting or whether it's fraction to decimal or decimal to percent, as long as one of those 3 are correct, you're going to get it right. That's just the practice we're in.